Are you able to see my screen?
Yes, sir.
Okay. Dear participants, today I am planning to give you the two lectures combined together. One is structural health monitoring of cable stayed bridge. This is actually we have completed under my supervision. I was a project leader for that. During that time, we have completed this entire cable stay bridge condition monitoring we have done. That is structural health monitoring system. So the cost of the project is 2.27 crore rupees. That is for including all the hardware and software and so on. That time we have used LabVIEW 7.1. In the year 2000, we started this project. This project completed by 2004 and successfully commissioned on 2004. And even now, the health monitoring system in this bridge is working. This is at Allahabad, UP. So near Triveni Sangamam, this bridge is there. So that experience I am going to share now. So in the structural health monitoring means these are the responses we have to find from the instrumentation. That was the objectives. One is design verification. Number two is alarm for the safety. Number three is proper maintenance, periodic maintenance. And number four is traffic regulations. These are the four objectives before going into the structural health monitoring system. And for each one, we have a different parameters. We have a load effect parameters and bridge response parameters. The load effects are the vertical load and as well as the lateral load and as well as the thermal load. The lateral load is wind loading. Thermal load is a temperature responsive and the traffic load due to moving vehicle. The bridge response is the structural integrity with respect to moving load or thermal expansion or for example wind loads, how the structure is behaving. Next, the changes of geometric configurations. Due to thermal, there will be expansions. So that expansions and all we have to measure and how the stress distribution is based on that. Because of the cable stay bridge, the tensile force in each cable due to the moving load is also measured. Then entire thing, the stress strain distribution of the concrete girders in the bridge deck also measured. Now this is a simple layout of the cable stay bridge. The cable stay bridge also looks like the same type. In that initially we have made, this is the design. The layout are made like this. There are 7 units we have planned. 7 units means 7 standalone systems. So there are 5 at the deck level and 2 at the top of the pylon. So these are the configuration of the bridge. The 2 pillars which is standing, that is called it as pylon. The roadway which is a deck slab. And during the surveys, the road is allowed to sway only on the linear direction. The lateral direction is restricted. That is the way design has been done. Now this is the different kinds of sensor distributions in each units. The unit 1, we have SG, that is strain gauges. There we have used vibrating wire strain gauge. We numbered 1012, 115, 15 strain gauges we have used in that. All the strain gauges were embedded into the concrete. And deflectometer, that is used outside the concrete to measure the linear expansion. In a highly summer season, this entire structure is going to expand. So that expansion can be measured by DEF, that is called it as deflectometer. During winter season, it may contract also, that may also measured. So correspondingly, the measured deflection with respect to temperature is done. Then through that, we can be able to measure actual coefficient of expansion or coefficient of contraction. Then next we measured accelerometer, which is called it as ACC 101 and 102. There are last two cables we took. On that, permanently we fixed an accelerometer. We procured from the Kisslers. So the triaxial accelerometer capacitance type we prepared. I will show you the photographs, all these things. And we measured every 15-minute acceleration. Through the acceleration, we could be able to find what is the load, what is the force in each cable. So for that purpose, unit 1 it is made. And unit 2 is situated at the center of the pylon. There only strain gauges have been given. 28 strain gauges are distributed in that location. Some of them it is in the pylon, some of them in the deck slab. Unit 3 is the top of the pylon. There we have placed only 4 strain gauges, and at the top one GPS is placed. Why GPS is required? The swinging, this displacement of the free end of the pylon is measured by global position station. Like that, unit 4 we have different sensors. Unit 5 we have, that is also again on the top of the pylon. There we have used our meteorological sensors, the wind, rain gauge, temperature and relative humidity, barometric pressure, rain gauge, then GPS. So this is kept on the top. Each one is linked with the response of the bridge. Like that, the ditto 1 and 7 is same, 2 and 6 is same, 4 is combined, and 3 and 5 with respect to strain gauge is same. In the 5 we have added more sensors. So now these are the distribution of sensor layout. Now you are seeing that each unit is working as a standalone system and it is connected with the hub. So the hub can take up to 90 meters. So every 90-meter hub is provided for signal, I think, distribution. So that you can see in the bottom, the unit 1 and unit 3 and unit 4, which is in the same location, same section. So there one hub is there. Between unit 1 to unit 2, one hub is there. Then again, because all the whatever this signal is coming based on the data acquisition and through hub, and this is the sensor, this is the signal network, and it is coming to the controlled computer. You are seeing here, these are the hub connections within the bridge. Then at the last, at the 7th unit, we placed the fiber optic hub. That's the duty is changing of normal hub to fiber optic signal. Then from fiber optic signal, it is coming to the nearest control room, which is 2 kilometers away from the bridge. So that again it is converted to the signal, fiber optic signal to electrical signal, and it is given to the controlled computer for further processing. So this is the general network for data acquisition, sensor, and as well as network layouts. So I am going to give you some highlighting about what are the different kinds of a sensor. Now this is a sensor, is called it as vibrating wire strain gauge. So this is what it will do. How we have to measure is the signal. How we have to measure is we have to. This is electromagnetic type. At the center of that there is 2 flanges available. Within this, a wire is tensioned and it tightened. So what happened? The magnet is provided, the electromagnet. Whenever the electromagnet is on, it will attract this wire, and after that releasing, then this wire will oscillate. Wire oscillation can be measured by induction. So that in terms of pulses we are getting, the pulses in terms of strain we can able to convert. That is the general mechanism in the vibrating wire strain gauge. So this is accelerometer, triaxial accelerometer. So here we have used X, Y, Z directions. This is we are not used. This is a encapsulating strain gauge that we are not using. The DEF I said, that is displacement sensor. What happened? The magnetic position will be here. This is the permanent magnet. Whenever this is connected, the magnet can move. So this is two part. One is fixed part, another is moving part. When the magnet is moving on this guy, it will induction is created. Then the voltage changes will be there. So that voltage changes we can calibrate to the distance. So that will give you how much it is expanded, how much it is contracting. So this is the method. This is the displacement sensor that will be giving induction. So this is method of positioning. There is a two girders are there. There will be a gap, that is expansion joint gap. That one is to one side of the girder, and the ring, the magnetic ring, is fixed on the other girder. So the movement will be there, and this will be moving. Correspondingly, we will be getting voltage changes. Now this is Kappa meter. This is using chopping type, that is IR based sensor. How much rotation is there, that can be measured. And correspondingly, that the direction is measured based on the potentiometer kind of thing. So the potentiometer is rotation. Based on that, we can calibrate for 360 degree. And after that, this is used. So there we are measuring the resistance. And here we are getting, this is temperature and relative humidity. This also gives a voltage corresponding to the temperature and relative humidity. Yeah, this is the mounting gadget. Now this is air quality sensor. From this we can find the low. Yes. So this is also again infrared uses, and how much contamination is there, that correspondingly calibrated. Please someone can please note. Mr. Rambabu.
Yes sir, I'll check sir.
That is disturbing a lot.
Yes sir, I'm muted sir.
Okay, thank you. Now this is barometric pressure. Directly voltage with respect to pressure, we will be getting the output is voltage. This is the rain gauge. Again here, these are the color coding all available. Based on this, we can able to get the voltage with respect to number of centimeters. This is the GPS base station. Yeah, this is working with your satellites. Yeah, this is strain gauge installation. Before concreting, we have to install like this, and the concrete pouring during that time, we should be very careful. They should not get damaged. And this is the way we have placed the strain gauge into the concrete. Now this is you are seeing that the construction sequences are going on. So this is the pylon construction first, and after that deck construction. Yeah, now this is going on. This is our people are standing over there during the concrete, and they are checking the our strain gauges. The pylon is from the deck slab. It is 80 feet height. You are seeing that this is deck slab side. From above, it is 80 feet. Now this is the deck slab. Yeah, our people are working on that. Then from the sensor cables are routed through ducts. We place ducts inside during the concreting. Then through the duct, we are taking out all the the signal cables. Yeah, our signal cables are out. So these cables further it will be taken to the unit boxes. See, our signal cables are above the concrete, this came. Now this is the one accelerometer we placed on the cable, and this is the gadget we have used for placing our accelerometer, and it is very well fixed. When the cable is vibrating, then that will sense, and we are sensing. Even now this is working. So 2004 I have handed over. Now after 16 years also this is working in good condition. Yeah, these are unit 1. I said these are the sensors we have used. Yeah, this is different locations where we have placed in the concrete structure. This is the anchorage section. There also we have placed VW strain gauges. Yeah, these are the close-up views. This is unit 2. All 48 strain gauges have been placed in different location. Unit 3. This is, yeah, this is unit 3. Unit 4. There we placed here also one more the cup anemometer. This is very, very important. Anemometer will give you the wind speed and wind direction. So suppose if any turbulence is there, we can measure the gust also. So this wind vane, so how much rotation it makes, each rotation is called as one gust. By that way we can able to understand that is the turbulence. And this is another 5. Now this is a general layout for the hardware. In every unit we have one network module. It's like our computer. This is the main module. From this, then there are input modules we used to add by in rails. So there are terminal bases available. The terminal bases corresponding to the channel, we can connect all the signal cables. Yeah, this is called it as Ethernet module. That time it is we have used field points. Now the field points is outdated. Now they came out with the compact Rio that is working better, and also compact field point also available. So that now people are using it. So with the higher memory and all. Those days we have suffered a lot because the memory is very less. So because of that, for making standalone system, we struggled a lot. Now in stereo and all, we have a more memory capacity. So with that, we can achieve very easily the health monitoring system very well. Yeah, this is one of the input module, that is 140 SG140, to measure the resistance. Directly we can measure the resistance. So which are the things are comes under resistance is, so your temperature resistor, I mean temperature comes under resistance, and strain gauges which are coming in resistance. And also there is wind vane, we are measuring the resistance. This is called it as CTR 500. It is used as a counter. So we require for measuring the pulses. For measuring the pulses, we have to have a counters. So that is called it as the counter module. So this will excite. For example, strain gauges, we have to give a pulsating pulse. We have to excite. The pulse also is a triangular pulse. That means varied pulse. For example, 150 milliseconds. Within that, we have to have a ranges of frequencies 900 to 1300 hertz. We have to excite. In that condition, this will excite and it will be giving the, for example, the pulses, induction pulses. That is with respect to frequency of that particular time. So that frequency we will be relating to the engineering data. This is again 120. This is RTD. This is also for resistance measurements. And this is one of the example for unit 1. What are the hardwares we have used here? So for example, this is Ethernet hardware. The bottom there is a railing, and over the railing all the terminal bases are placed after the this Ethernet module. So this Ethernet module is that is called as 10 by 100 base Ethernet module. So in that we have got everything, the railings. Okay. So now over the terminal bases, these input modules have been placed. So the terminal modules are common. The input modules are varying, depends upon the intended purpose. Now this is the real drawing, the design that we have. Before making installation, we prepared proper drawings. So for example, unit 1, we have placed this drawing. So with this drawing, anyone easily they can able to understand what is inside, and correspondingly how we have to fit it, everything they will easily understand. So here you see that the railing, this hardware, what are the things is available, which is given. So number first one, this is a power supply unit. 12-volt power supply is required for Ethernet module, that we have given. After the power supply, these are the terminal bases. Over the terminal bases, analog input and output modules have been given. So here, for example, see the AI means analog input module. CTR 500 mean for generating the pulse generator, we can do that. And RTD module, which is called it as resistance. RTD measurements is based on resistance. So we can make resistance also in measurement in this. Then the DO410, this is for excitation. For example, in any accelerometer, we have to excite with 5 volts. For that, here this DO module will excite 5 volts, and correspondingly the response will be measured in A100, analog input module. And all of the displacement sensor also giving only the voltages, change in voltages. So these and all, the displacement sensor and accelerometer, so these things, it is coming to A100. Then again there are strain gauges that uses CTR 500 and as well as there is DO410. So within these two, we can able to measure exactly the frequency of the signal we can measure. But for that, we have made our own. See, since we have a 15, one not one to say 15 strain gauges we have. So all the 15 strain gauges, we have made a mux operation. So since only one channel we are going to use in that, the strain gauges having, it is sensing the strain also by way of pulses, and also the same strain gauge has the temperature sensor also. So in the concrete at a different time, the temperature can also be measured. So the temperature is measured directly in the RTD, and the strain gauge is measured in the CTR 500 with the help of DO410. For that we have separately conditioning, that separately we have embedded there. This is the external hardware we have added in the NI, and here also there are SG module also we have added separately. Okay, so these two we procured from Cage Techniques. This is the multiplexer, and the AVW. This is for the conditioning. And after that, this we have made further to measure in terms of frequency. We have got our own module. We designed and we embedded there. So this is the unit 1. Like that, unit 2 and unit 3, unit 4 and all. So right side in the reference, you can see that whatever be the sensor which we are using, the color coding also we have given here. So with the help of the color coding, they are able to know that which wire is for what. So like that, everything is done. You are seeing here, this is one of the another unit. So in that unit 5, the unit 5, we have more numbers of sensors. All the pin configuration is given. And each unit, it is connected to the Ethernet hub. So then from that, it is going to the control room. So the sensor installation part. So now what we have to do, how we have to do the health monitoring system. We have to procure, first we have to make complete design. Which are the locations we have to place the sensor? That you require some civil engineering knowledge. So consulting with the civil engineer, then we have to properly locate the sensors exact in a critical position. So after that, what are the types of sensors required also, we can discuss in consultation with the design engineer, and the different kind of sensors also decided. When all these things over, then first we have to make a design of sensor placement, number one. Next we have to do design of a hardware. What kind of a hardware we have to use, what are not available, what are the additions of the hardware, how we are going to operate, that also we have to design. When that is over, we have to go for the power design. So how we can give external powers, uninterrupted external powers we have to give. For that, what are the designs? So that layout also we have to prepare. Then again, what we have to do, we have to go for the complete design is over. Then we have to go for that sensor network design. That means the signal network design. That also to be done. So all the design is over, then we have to procure the sensors from various sources, and after that in the laboratory we have to calibrate, and after calibrating laboratory we have to measure the sensor readings in ideal condition. Then after that we have to embed into the concrete. After the concreting is over, then we have to take once again the reading. That is called portable data acquisition system. This we have used PXI systems of NI hardware, and that is portable, and this one we have used for measuring at the site. So then and there, whenever we require, we used to measure the sensor readings. That manually we kept it. The data we have kept it loaded manually into the control computer. And after that, the evaluation part, which is completely automated, that is called it as computer system and operation and control. This is called CSOC. So now data acquisition we have used, I already told you, the field point modules we have used for the entire bridges. So that was very rugged, even up to 17 years. There are one or two modules they have not worked in between. Then we have changed the same modules, and even now still it is working. Now the National Highway Authority of India, they are planning for modernization of the same instrumentation system. The sensors will be inside, and only thing the hardware can be modified. That we proposed for the compact Rio modules. And overall, that time we have used LabVIEW 7.1 for all the coding purposes. Now this is the GPS data. This is the one we have used. That is the force measurement we have used with the portable data acquisition system. The accelerometer is continuously there, but before making commissioning, we have to have the forces requirement, because when you are fitting these cables, how much force that is taking up, that has to be verified. For which we have used portable data acquisition system. That the accelerometer reading now you are seeing in the first graph, which is actual acceleration readings, and after that FFT analysis, this is giving a fundamental frequency. So this with that we have further calculated what is the force in the cable available. This is using the simple harmonic motion equation method, and the next one we have done. See, this is the formula 2FL by N mu divided by 1000. If you are not dividing by 1000, you will get it into Newton. Okay, so 2 is a constant we have to use. F is the fundamental frequency. L is the length of the cable. N is the mode, in which mode that is oscillating. The mu is the per meter length. What is the density of that particular, what is the mass of that particular material. Here that is the steel, that also we have given for different length and all. You are seeing in this tabulation all yellow color, that is measured by our own accelerometer, and the all black color which is measured by load cells. Now we have seen that in the here the error is very less, that is minus to 0.1% like that. the measured load cell also, and as well as accurately what we measure. So that itself proves that this is one of the very best technology to measure the force in any of the cable by way of the vibration measurements. Now this is the horizontal displacement with respect to temperature, that is in the deflectometer response. Now this is the displacement versus temperature. Now with respect to temperature, you are seeing that there are displacement is more. The less temperature, you are seeing that in the zero and the contraction will be there, but it is very linear. Now this is the one of the data acquisition. This is we have made for strain gauges, encapsulating strain gauge in the laboratory. This is not required. This is kind of a control room we have to get, but we have a different kind of a control room. So my dear participant, this is the work actually first time in India. Under my leadership we have done. It is still working in Allahabad, sponsored by National Highway Authority of India. I wanted to show you the actual video which I took from the site. That I am going to explain you. I'm just playing that video. Sorry. You just see that it's a self-explanatory. Then once again I will play and explain. So here I want to explain. Actually, everything is automated. This screen exactly available, what available there in Allahabad. So we made the presentation, that is the report presentation like this. And also this is enabled with internet. The people from Norway, that is our consultant, he used to check from there. And also National Highway Authority of India, they are the client. They are also checking from Delhi. So we have also checked once from our CSIR, and then after that we completely hand over to the maintenance team. Now they are doing it. How this is made? You see that in the entire figure, this is the photograph which during the completion, and here the unit 1 and all those things we have placed. When you click unit 1, automatically it will go to unit 1. There also you can click. Here in the downside, unit 1 to unit 7 is there. There also you can click. So anywhere you can click, you will get the data. Next, in the right side bottom, you can see that. So with historical view. So when you click here, then automatically it will go which unit you wanted, and there you can which sensor you wanted to see the historical view, that you can see. Then every 15 days you can take the backup. Automatically it will be getting the backup. And suppose we have already given the limits for all the sensors. If any problem occurs, this bus mode will blink. Not only here, and the bottom it will show which is the sensor and correspondingly which is the unit. Now here the bus mode is given as 501. 501 is the vibrating wire strain gauge. So we can go there and we can see at that particular location what is the problem. So like that, these are the provisions we have given in that. You see, suppose for example, when I click there, unit 1, automatically this window will open. In that window, exactly that diagram will be there, and the timestamp when we have done the same 2007, this video we have taken there itself, and that timestamp is available. And correspondingly, this is the deflectometer. So here it is the accelerometer reading. We have 2 accelerometers, so 6 channels are available. And here at the bottom, 15 strain gauges. All the 15 strain gauges we have the temperatures and as well as the strain. Directly we have converted into strain. So like that, you can able to get completely in each units. You will be able to get the data. Then after that, this is when you are clicking the backup, it will automatically open this window. There we have to give the file number or file number with the date. Automatically that will store. The storage is already mentioned where the database we have given, there it will be storing. Yeah, this is the file storing. Now this is the historical view. If you are clicking the historical view, then automatically, the file automatically we have to select the file. Because the file is already we have made, that file is opening. And we have to add which are the sensors. So if you are adding, you have to select the sensors and add, and correspondingly you can see the value. So that is the next option. See, these are the sensors. Now it is popping up. In this sensor, we have to select and add. It will be added in the right side. Which are the sensors if you are doing? Then after that, if you run, then you will get the historical data. So now after running the next window, you will be getting the historical data. Of now 4 sensors we have selected. The date and time and all given. If you are giving a date, proper date and time, it will give you exactly. And like that, we have the bus mode operation. So I think with this, I will be closing the health monitoring system. If you have any doubt, you can ask me now. Then after that, I'm going for the next one, condition measurement. Anybody having any doubt, you can text me. I'm just waiting for a minute. Is it okay? Is it Manjushri? Do you want to talk something? Yeah, you can text message. In your question, anything is there, you can text message. Okay, if no response, I will be going for the next presentation. The next presentation which is given, I think someone has given some message. Yeah, this is Sabida says that continue. Okay. So here there is in Bangalore, one of our client, they wanted to check their structure. So this is the plan of the structure. It's a big building, very big building, and also multi-story building. This plan shows the basement. So the basement, two basements they have kept for car parking, in which I have rounded off 4 places. All the 4 locations, they were completely water is leaking. They came to us and we have taken this as a project, and we have done measurements, non-destructive testing measurements, and given the readings and also given conclusions. Accordingly, they have rehabilitated. Yeah, now it is in very good condition. They had spent around 1.2 crore rupees for repair. Right now, the structure becomes very good, not even single drop. Then this is 3 monsoon is over. I think 3 consecutive years is over. No problem so far they faced. So that I am sharing with you. So we have made, these are the NDT measurements. Number 1 is first visual observation. And after that, there are electrochemical measurements, which is open circuit and surface potential. Thermal measurements we have made, and rebound hammer and sample collection and laboratory analysis. Okay. So this is the general non-destructive testing. Then why I am showing here? Here how the NI product I have used, how the LabVIEW I have used. For that I am going to give you explanation. Now you are seeing that. See, for example, you are seeing that this is the actual condition. The completely they are soaked by water. These are the locations. Completely you are seeing that the soaked by water, right? Yeah. Now this is the one I wanted to explain you. So we have taken electrochemical measurements. And after making electrochemical measurements, these values have been properly mapped. Because of the mapping, we can able to compare exactly on the photograph that where it is leaked. So correspondingly, there is a negative potential, more negative potential, which is responsible for corrosion and as well as degradation of the materials. So that negative potential area we have found, those locations, they have to make a repair work. That is the idea we have done. So this again you are seeing that there are open circuit potentials we have compared. The mapping is done. So that itself shows the negative potential on this direction. So the water is flowing from here to here. Here also the same thing it shows from this side to this side. So then we have checked actually above the basement there is a water plant. Okay, a fountain is there. Based on the foundation, all the water is leaking. So because of that, the water is seeped inside and it is got completely leakages. That we found and we have given them. So this is also again about the different locations like that. Yeah, this mapping also given like that. These are the different locations, different mappings. Yeah, this is the thermal analysis. This is not connected to our NI codings. Rebound hammer, and these are the laboratory analysis. So now I wanted to show you the real time, how the mapping is done. This is our coding. For example, whatever the potentials we measured, I have already stored in a separate Word file. What I am doing, I am just taking some of the data. So now I am taking this data. Okay. Now I am running. This is automatically we will be getting the mapping. So we are getting the mapping. So in that mapping, you can able to see that wherever the less potentials, that is the grayish color, this area is highly vulnerable. So this location we identified in the photograph, exactly on the location also, that we have marked, you have to take a repair on those locations. That they have done. So here, The coding is a challenge. This coding is not available ready-made. We ourselves developed this coding. As usual, last time I told you, this is the data reading module. For example, this is in this that will read the file path which I have told you. See, for example, this is the file path. That we have to show the file path, and from that it will read. And after that, that is read, and the output is given as a array. The array is made as a local variable. Yesterday we have seen what is variables. Now I have made it as a local variables. Sorry, global variables. Now that variable is used wherever we want. We have used it. So now the principle, how this mapping is done. I will show the principle. These are integrated with sub-AIs. Yeah, this is actually the principle. Yeah, this is the brain behind it. So if you are able to complete this is the major coding. This coding is the principle for this entire mapping. So this is we have done. What we have done, we have taken in suppose X and Y direction, we have taken 4 points. I'll be explaining in the paint. For example, I am taking just 4 points. So for example, I am making 100 and 200 and 250 and 400. These are the 4 different voltages. 100 millivolts in one location, 100 millivolts at one location, and 200 in another location, and 250 another location, then 400 some location. Now this is the actually readings from the sensor we will be getting. So now what we are doing, how we have to make a mapping means, I am making this as a I think 10 parts. What I will do, I will be making as a 10 parts. So for example, let us take a 2 parts. Okay, and the same way we can do that. So you can have any number of parts. The concept is same. What I have to do now, this is 200, this is 100. We have 0, 1, 2. Okay, 0, 1, 2. Now this is the location 1. The location 1, now this is 200 minus 100. Okay, 200, 2 within that 200 minus 100 divided by 2, right? So what it is, 200 minus 100, which is 100, divided by 2 is 50. So now I can get this particular portion because this is negative. I am getting minus 50. So 200 minus 50 is 150. So I will be having 150 there. The same way, now this also I am making it. Here 200 plus minus 400, this is minus 200. So minus 200 divided by 2, then that will be 300. So that is 300. And again, this side will have 150 divided by 275. So which is 175. So this side 250, 400, which is 150 divided by 275. So that is 325. Okay. Now the coding is to be done like that. Okay, what is the center between here and here? This is 300, 175. It is how much it is coming? 175. 175 divided by 2, which is how much it is? 175 divided by 2, which is 87.5. So 87.5 means, just 1 minute, 175 plus 87.5. So 175 plus 87.5, 262.5. Automatically it will come 262.5. So now this is the center point. Even you can verify both the side, it may come like this. So now this value you have to arithmetically plan, and that you have to convert into coding. So when you make this one particular segment, then correspondingly number of segments available, it will keep on taking and it will value like this. Then after that we have to have, for example, if you are having more numbers, correspondingly it will have a mapping by drawing the methods. Okay, so that way we can have a codings. So that is the one we have used here. So one by one we have used there. So this is the coding. I have taken 4 locations and I have divided into, so how much 100 times or even 1000 times also, as like finite element methods, we can have a small millivolts. So that is the way we can go there, and finally we can arrive exactly for different numbers. That numbers will be available. Further, those numbers we have to process. Then we have to find correspondingly the drawings. We have to make a drawing. This is the method of drawing. So this will give you the drawings. For example, we will be having in this, just a minute. Yeah, here this these tools we can use for making all the drawings. A graph, a picture node, and all picture functions. So where you want to put, everything is coming over here. So with these tools you can able to draw the complete mapping. So first principle is a mathematical principle. After that you are going for graphical principle. So that is the way this coding has been developed. So that's all, my dear participants. I think I am finishing now. Now if you want to ask any questions, you can ask. Mr. Rambabu?
Yes, sir.
Yeah, please, you can, if anybody wanted to ask any questions, we can have interaction.
Yes, sir. Dear participants, any questions you can ask Krishnan, sir. Yeah, we'll send you the attendance link. Don't worry about the attendance link. Within few minutes, I'll be sending the attendance.
Okay, I'm stop presenting now. Yeah, now this is the question time. You can ask a questions. All faculty, you may have so many doubts. You can ask me. Then after that, you have to wait for the next FDP. If you want to ask anything, you can ask now itself. Yeah, if you want to message also, you can message. Okay, Mr. Rambabu.
Oh, yes, sir. Okay, sir.
If nobody is asking anything, no problem.
Okay.
Shall we
Thank you,
close?
sir. Yes, sir. Thank you, sir. Thank you for the presentation, sir.
Yeah, thank you.
I'm giving the attendance link. Okay, those who have given the attendance, they can leave, and you people can join back tomorrow for the final days session. Tomorrow by sharp 9:20. I'll be giving the link, joining link tomorrow. Thank you for joining today.